I'm Presh Talwalkar. Suppose a square contains a semicircle and a quarter circle as shown. The semicircle and quarter circle are tangent to each other. Suppose the semicircle has a diameter equal to 12 and the quarter circle has a radius equal to 12. There are two parts to the question. First, what is the area of the square? Second, construct the tangent line segment AB. What is the length of AB equal to? This problem is adapted from one by @cshear41 on Twitter. Pause the video if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. Recall that if two circles are tangent, their centers and the tangent point are collinear. That's because each radius will be perpendicular to the tangent line. Therefore, ATB will be a straight line segment. This is true for both externally and internally tangent circles. So now let's solve the problem. We'll first construct the center of the semicircle, the center of the quarter circle, and the tangent point. These 3 points will be collinear, so we can construct a line segment between them. Then, the semicircle has a radius that's equal to 1/2 of 12, which is equal to 6. We can then get the dimensions of this line segment. It will be the radius of the semicircle and the radius of the quarter circle. Let's now focus on just this right triangle. Suppose the remaining dimension on the side of the square is equal to x. That means the side of the square has a length equal to 12 plus x. So the other side will also have a distance that's equal to x. We can then solve for each side of this right triangle. The hypotenuse will be equal to 6 plus 12, which is equal to 18. One leg will be equal to 6 plus x, and the other leg will be equal to 12 plus x. We'll then focus on just this right triangle. Because we have a right triangle, we have 6 plus x squared plus 12 plus x squared is equal to 18 squared. We can then systematically solve this equation for x. We will use the quadratic formula and we'll get two possibilities. Either x is equal to -9 plus 3 times the square root of 17, or x is equal to -9 minus 3 times the square root of 17. But recall that x is a length, so it should be positive. So we will eliminate this negative value. We thus get a value for x. We can substitute it into this side of the triangle. We will simplify this to solve for the side of the triangle. Recall that this side of the triangle is also the side of the square. So we can get the area of the square by squaring this length. We can simplify this and it will be equal to 162 plus 18 times the square root of 17, which is approximately equal to 236.216. And that's part 1 of the question. Let's now solve part 2. We need to solve for the length of AB. To get started, the tangent line AB is perpendicular to the radius of the quarter circle and the radius of the semicircle. We'll then focus on this right triangle. Suppose one angle is equal to alpha and the other angle is equal to beta. Now consider this right triangle. Since one angle is equal to alpha, the other angle will be equal to beta. Now from the point A, construct a horizontal perpendicular line segment. We have another right triangle here where one of its angles is equal to beta, so the other angle will be equal to alpha. Now compare this right triangle with this right triangle. What can we say about them? Well, these two right triangles have the same measures of their angles. We have alpha and beta, and each of them has a longer leg that's equal to the side of the square. Therefore, this blue triangle is congruent to this green triangle, so their hypotenuse lengths will be equal to each other. We know that the length of the hypotenuse on the green triangle is equal to 6 plus 12. Therefore, AB will also be equal to 6 plus 12, which is equal to 18. And that's the answer.